This video will show how to create an autoscaling cluster on Ansys Access on Microsoft Azure. First, let's review some autoscaling cluster basics. At a general level, an autoscaling cluster is a cluster that scales up and down depending on workload. As implemented on Access on Microsoft Azure, the autoscaling cluster has several components. There is one or more shared storage drives where the applications are installed and which the applications can use while they are solving. There's also a head node, and there are multiple worker nodes, which could be static and or dynamic. These components are all connected to each other, and these all make up the autoscaling cluster. This video will show the creation of all of these parts. In future videos, we'll talk about other components that sit outside the autoscaling cluster communicate with it. Most important is a Linux VM with a Slurm client for submitting jobs to the autoscaling cluster. So I have this new project space that my tenant admin created for me. It is not a requirement to have a new empty project space. There could be any number of VMs in here, any number of virtual desktops, but there can only be one autoscaling cluster. So if there's an existing autoscaling cluster in this project space, you either need to create a new project space or delete the existing autoscaling cluster. Before we begin, I'd like to talk about the documentation. I recommend you look at the documentation when you're creating the first autoscaling cluster. It can be reached by clicking on the help. Especially want to point out a couple of sections. One is the administration guide, especially the section on autoscaling clusters. Creating an autoscaling cluster. We'll go through the steps that we're about to go through. And then also the recommended usage guide. There's recommended hardware, recommended best practices, including for general Slurm clusters and autoscaling clusters, and especially here the recommended configurations by application. Each of the applications may have requirements and recommendations specific to it, so it's best to look through. In this video, I'll be creating a cluster for both Electronics Desktop and for Fluent users. And you can see that in these steps, there may be some differences. If we click on and follow the steps here, there may be more details that are different. So I suggest looking through the recommendations guide for each of the applications that the autoscaling cluster will support. Okay, let's create the cluster now. Go to New Resource, Autoscaling Cluster, which opens up this page. All of our choices will be on this page, which creates all the resources, the shared storage, the head node, the worker nodes, and at the end, we just create autoscaling cluster. It does all this in this one step. So we just need to go from top to bottom and make all of our choices. In the storage section, there's existing storages. If there's an existing storage in your workspace, it'll be listed here, and you have the option to mount it or not. You can also create new storages here, of which there are several choices. Azure File Storage, NFS, Azure NetApp File Storage, also NFS, which will give faster performance, and Azure File Storage SMB for Windows access. So if you want your storage to be accessible from a Windows VM, you need to use SMB. But SMB is not a choice for application installation on the autoscaling cluster. So we must have an NFS. We'll just choose the basic file storage NFS. We have options for storage capacity. The low end should be enough to install the applications, but when the applications are using the storage for doing their solves, they may need more space. So consider the needs of your users there. Next, we need to provide the storage name and mount path. We could move on here, but I will make a couple of points first. One, we could add additional storages of different types. For example, you might have the applications installed on the Azure file storage and provide a faster file system for applications to make use of. Another thing to note is if there was a previous autoscaling cluster in this project space, which already had applications installed on it, the storage may still exist and you can just reuse the previously installed applications. So by selecting the same storage, you can skip the installation step and save several hours of installation time for these applications. Once the storages are configured, we can add our applications. These are the list of applications available. I will be installing Electronics Desktop and Fluids. So first I'll choose Electronics Desktop, choose the installation location, and then add whatever information is requested. In this case, the license server and one other question. I will then add the Fluids. Again, choosing the location, which could be different from Electronics. And again, a license server. I could add additional applications, up to as many as you need. And then we move to the head node. The head node is a lightweight node that's going to be running the entire time the autoscaling cluster is running, even if no solves are happening. They're to, running to accept jobs submitted to it. There are 3 configuration sizes by default. You can also have a custom one if you want to. I'm going to choose the ultra high. And I can also choose a system disk size. Then I'll move on to additional cluster options. So we've talked before about dynamic nodes and static nodes. Primarily, we expect users are going to use the dynamic nodes. They don't cost anything when they're not being used. So when the user submits a job, the dynamic nodes spin up. The job finishes, they shut down. This question is about how long will the dynamic nodes wait before shutting down. Too quickly, the users may be ready to submit the next job, and then they need to wait because the nodes need to spin up again. If you're expecting that maybe users will be submitting multiple jobs in a row, maybe make more sense to keep those nodes open so that they can start their next jobs faster. So this just gives an array of options for those dynamic nodes to stay running. The last big step is to create queues. Queues are important because it determines what hardware the jobs will run on. When a user submits a job, they select from the available queues. Each queue can be assigned to one application. So since we have 2 applications, we'll need at least 2 queues. But it's often beneficial to have more than that. In this case, I'll create 2 Fluent queues, one for larger jobs, one for smaller jobs. So I'll call this one Fluids Large, and I will select some hardware more appropriate to larger jobs. I can select a specific hardware from here, whatever is available from the list, or I may just choose from the templates. These templates are based on the recommended hardware for the given application, so they're usually a good place to start. I'll take this 96 core HBV3. I then have a choice of choosing a number of static nodes and number of dynamic nodes. Usually you'll have dynamic nodes. Static nodes might be under specific situations. The risk of static nodes is that they'll be left idle and you'll pay for them when they're running, when there's no need to have them run. So usually we'll just have dynamic nodes. You can set the maximum number. There's a couple cases where you might consider static nodes. One is if you have very high and consistent usage for your cluster. But even then, dynamic nodes will be okay because they won't shut down. As long as we have new jobs coming, the dynamic nodes will stay running. Another situation might be if you have only a single user for the cluster, and that user just keeps the cluster shut down most of the time, only turn it on when they're using it, in which case static nodes may be okay. There's a few advanced options here. Usually don't need to change these. If the application needs more disk space, you could increase it here. And then there's an estimated cost, which would actually be the maximum cost. We'll talk more about cost later when we review. So that queue is done. We can just keep adding more queues. Again, I'll add another fluid. I'll call this one Fluid Small, and I'll choose the HC44 in this case. I can choose a different number of nodes. So having a second queue, obviously for large and small jobs, but also as like a backup in case one is full, or in case there's some issues with the availability of the hardware at this given time. So it's always nice to have a backup queue. I'll create one queue for electronics. Notice the templates are different for each application, so I have different options here. And I'll just say this is good and move on to the next step, which is just to finalize. So I can add my tags, name the cluster, and then there's a cost summary I can look at here. And again, this cost summary includes all of the hardware that could be running. This should be seen as a maximum cost per hour. So when the cluster is turned on, if no jobs are running, only the head node will run. These three queues are all using dynamic nodes, so they'll only be incurring costs if there's an active job running. And from here, I can create the autoscaling cluster. Once the creation process has started, I can now see the resource in my project space. I can click on the cluster for more details, and we'll come back here later once the cluster is running and discuss this. The cluster has moved on to installing status, so we can get a bit more information about it, notably the private IP, which will be used in further steps. We can also see other information, the queues. We created 3 queues. Obviously none of them are being used right now. The applications we chose, the 2 applications and their installation status, and the storage. We also have the control here to stop the cluster and start the cluster if it's not running. Now this will stop the entire cluster, including the head node. When you start the cluster, it will start the head node, and any static nodes. The dynamic nodes obviously will start whenever they're needed. If you need to completely delete the cluster, you can go to Settings and delete Autoscaling Cluster. This will delete the head node, all the queues, but it will save the storage. If you want to delete the storage, you can do that separately through the project space controls. And there's also an option to connect using SSH. So we'll return here once the applications are fully installed. The autoscaling cluster is now running, and the application install status is completed. This autoscaling cluster is now fully ready to be used.